Huge upgrades to Starship design after recent incident. SpaceX is making several changes to the Starship design following the Starship Flight 7. The Block 2 upper stage will feature a new multi-feedline fuel system for the Raptor vacuum engines and redesigned vents to address pressure management. These modifications aim to enhance safety and reliability in future flights. Despite the upper stage's loss, SpaceX validated some new features during the test. The forward flaps, upgraded engines, and improved tile adherence during ascent were all tested successfully. However, the mission couldn't test the heat shield performance or payload deployment system due to the early breakup of the upper stage. The flight on January 16th faced challenges when the Block 2 upper stage broke apart mid-air due to a fire in the aft section. Musk shared that the preliminary analysis points to an oxygen and fuel leak above the ship's engine firewall, causing pressure to build beyond the system's venting capacity. However, Musk emphasized that this issue is not significant enough to delay the next launch, expected as early as February. He also noted planned improvements, including enhanced fire suppression and increased venting capacity. While the upper stage faced challenges, the Super Heavy booster demonstrated significant progress. For the second time, SpaceX successfully caught the booster using the chopsticks arms of its launch tower. Initially, only 12 of the 13 Raptor engines relit for the boost-back burn, but all engines were eventually restarted for the final landing burn. The booster, which included an engine flown on a previous test, landed safely 20 seconds after completing its approach. This achievement highlights SpaceX's strides in reusability, a critical factor for reducing costs and increasing the frequency of Starship launches. SpaceX has already begun refurbishing the hardware used in Flight 7. The company plans to incorporate lessons learned from the test, focusing on improving heat shield performance and ensuring reliable engine restarts. These advancements are essential for Starship's long-term goals, including satellite deployment, interplanetary missions, and spaceship-to-spaceship fuel transfer. Musk described the mishap as barely a bump in the road, underlining the company's resilience and determination to achieve its ambitious objectives. With the upcoming launch just weeks away, SpaceX continues to lead the charge in advancing space exploration and technology. Meanwhile, the Federal Aviation Administration is conducting an investigation into the recent mishap. The agency has confirmed reports of debris over parts of the Northern Caribbean, affecting several commercial flights. Airlines such as Delta, Frontier, and JetBlue experienced brief holding patterns or diversions as a precaution during the incident. SpaceX had issued a standard notice to air missions ahead of the launch, warning of potential debris over the Gulf of Mexico and the Caribbean. However, the unexpected breakup of the upper stage led to wider impacts on air travel in the region. However, the company's rapid development process emphasizes learning from setbacks while pressing forward with ambitious goals. The 8th test flight will play a critical role in validating additional features, such as improved thermal protection systems and in-space maneuvers. On the other hand, SpaceX achieved another milestone on January 21st during its Starlink satellite launch from California. A Falcon 9 rocket carried 27 Starlink broadband satellites into low Earth orbit from Vandenberg Space Force Base. The launch was followed by the successful landing of the Falcon 9's first stage on a drone ship in the ocean, just 8 minutes after liftoff. The achievement marked a significant moment for SpaceX as it completed its 400th orbital-class rocket landing. In other news, scientists have uncovered an astonishing find. 74 alien star systems are surrounded by rings of comets, known as planetesimal belts. These icy exocomets, numbering in the trillions, not only provide a glimpse into the composition of these systems, but also point to the origin of much of their water. This discovery is a significant step in understanding planetary systems beyond our own. The research, conducted using the Atacama Large Millimeter Array in Chile and the Sub-Millimeter Array in Hawaii, has shed light on these cold, distant belts. Temperatures in these regions range from -418 to -238 degrees Fahrenheit, making them too faint to detect with traditional optical or infrared telescopes. Instead, the belts emit light at longer wavelengths, allowing ALMA and SMA to observe them effectively. What's being detected are tiny pebbles, only millimeters in size, created from larger cometary bodies colliding over millions of years. These pebbles emit sub-millimeter light, which was crucial for this study. The belts are located around stars within 500 light-years of our solar system. Some are relatively young, while others are billions of years old. They vary in shape and structure, with some forming narrow rings similar to our solar system's Kuiper belt, while others resemble expansive disks. Interestingly, some of these belts are tilted or elongated, likely due to gravitational forces from unseen planets. Patterns have emerged from this survey. For instance, older systems tend to have fewer pebbles because the larger exocomets have already collided and diminished over time. Additionally, belts closer to their stars show a faster decline in pebbles. Researchers also observed signs of hidden, massive objects, such as moon-sized bodies, within these belts. These findings suggest a complex and dynamic environment within these planetary systems. The discovery highlights the diversity among these belts, with many extending farther from their central stars than expected. While some belts conform to the classic belt structure, others span wide areas, suggesting they may be better described as disks. Researchers also noted that belts closer to their stars, which would be warmer, might emit less detectable submillimeter light. Future observations with the James Webb Space Telescope could provide more insight, as it can detect these warmer belts and identify finer details like gaps or planetary bodies within the belts. The Reasons program aims to deepen our understanding of how these belts form and evolve. These icy regions play a critical role in planetary systems. Comets within these belts could be responsible for delivering water to inner planets, potentially supporting the development of alien life. Alternatively, comet impacts might pose threats to life by causing destruction. By comparing these belts to our Kuiper belt, astronomers hope to uncover the processes that shape planetary systems and the conditions necessary for life. The discovery opens the door to future research. With instruments like JWST, astronomers can continue to explore these distant worlds and their icy realms. The findings not only advance our understanding of the universe, but also inspire questions about the role these icy belts play in the potential for life beyond Earth. And that's all for now. Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.